So, my name's Chris Webb. I'm a member of the customer advisory team at Microsoft, which means I deal with all of the most difficult, interesting implementations of Power BI in the world. I've only been in the job a week. Before that, I was just a regular person, but I was a regular person with a passion. I love Power Query. And if you love Power Query, you can't avoid loving M as well. And that's what we're going to be talking about today. This is going to be an introductory session to the M language. I will assume no previous knowledge of M. Don't worry, it's not difficult, so you'll learn it all pretty easily. But even if you do have some knowledge of M, there might well be some things, especially towards the end of the presentation, where there are some less obvious things about the language that we'll cover. So even for the more advanced users out there, hopefully there will be something to keep you interested. In terms of what we are going to cover, we'll have a look at what M is and why we need to bother learning it. We will look at let expressions, data types, positions and lookups, error handling, functions using web services, and then the interesting things that I was going to talk about at the end, the more advanced stuff, streaming semantics and lazy and eager evaluation. Some of these things are things that are pretty confusing, not easy to test, and indeed I spent most of Sunday afternoon thinking that my demos had broken, and in fact they hadn't. It's just Power BI Desktop had changed its behavior. I've deliberately not upgraded to the new light theme of Power BI Desktop because I'm not so stupid to change my installation the day before I do a presentation. Okay, let's start with the absolute basics. What is M? Before we even talk about what M is, we need to understand what Power Query is. Power Query is a bit of functionality that allows you to do self-service ETL, extract, transform, load of data. So it allows you to connect to data sources, make lots of changes to that data, clean it up, transform it, filter it, do stuff to it, and then load it somewhere else. It's shared by a wide range of applications. It's present inside Power BI. It's present inside modern versions of Excel. It's present all over the place. It's inside Analysis Services Tabular. It's inside Azure Data Factory. It's inside Flow. It's taking over the world. Now, Power Query has a nice, friendly user interface, and that's probably all you might ever need to use. But behind the scenes, everything you do in Power Query is translated to M. What is M? The easiest way to explain M is that it is yet another language to learn. I know. We all love learning new languages, don't we? So everything you do in Power Query is translated back to the M language, and you can edit that M language. You can write your own M to do more advanced things. M as a language has quite a long history. It's been around quite a long time in various different shapes and forms. For a while, they decided to change its name to Power Query Formula Language because they thought that was a little bit more descriptive, and there are other languages called M. But by the time they did that, they realized that everybody was writing about it as M, and it was too late, so they just changed it back to M. Now, the next interesting question is, why do you need to learn M? Because like I said, the Power Query editor has a really, really, really good user interface. I think it's one of the best things about Power Query is that it's how easy it is to use. So for a lot of things, for a lot of even fairly advanced things, you never need to write any code. I'm going to draw lots of comparisons with the other language of Power BI, DAX. When I say DAX, maybe you can all boo, perhaps, in sympathy. You know, you're all Power BI people. You'll know that sooner or later you run up against the fact that you've got to learn DAX. And DAX is difficult. Well, for a lot of things, you probably never ever need to learn M. For a lot of advanced things, you never ever need to learn M. But, you know, we're all fairly keen, enthusiastic Power BI people, aren't we? And we just can't resist learning about every single possible bit of Power BI. So, you know, perhaps it's going to be a good idea to learn M just to see how things go. And of course, there are going to be some more advanced situations, some of them we'll talk about here, where you will need to edit a bit of M that the user interface has generated, or write your own M. Some things, for example, if you intend to connect to web services, you're only going to be able to do if you can write some M. Also, if you're really keen, you might decide you want to build a custom connector for Power Query. Custom connectors allow you to add new data sources to Power Query, and those are written in Visual Studio in the M language. So, that's what we're going to cover today, how we learn M. All right, next question, where do we write M? There are actually a couple of different places where we can write M. Let's go to Power BI. Here's Power BI Desktop, the old dark theme. I'm so out of date. We click Edit Queries, and this will open the Power Query Editor window. There we go. We can see that it's the Power Query Editor window. It says so up here, if you've never noticed that before. And I'm going to assume that everybody knows roughly how to use the Power Query Editor window to connect to data. Now, if I create a new blank query, this will create a new query, and this will show us a couple of the places where we can write M. The most useful place to write M is going to be in the Advanced Editor. So the Advanced Editor allows us to see all of the M code for all of our query. So if I right-click on here and choose Advanced Editor on the right-click menu, then I can see the whole M code for this particular query. And I can edit it here. You can see that it's not actually a blank query. We've got some code in here. We'll come back to that a bit later. Let's change something here. Now, we've got some data. I can start clicking some buttons. Let's perhaps add a column. The next place that we can write M is using a custom column. Custom column adds a new column onto an existing table. And I can write an expression here. This is another M expression. We'll do that. There is my new custom column. The last place we can see M inside the Power Query Editor is that if you click on a step and you've got the formula bar enabled, so if you go to the View tab up here and you make sure you have this formula bar option checked, then every time you click on a step, you can see the M code for that step. And you can edit here as well. Personally, I don't like editing the M code here too much. I always prefer to go to the Advanced Editor, but sometimes it's really handy to have the formula bar visible just so you can see what's going on. There are going to be a lot of situations, for example, if I was to remove column 1 here, you can't edit this step for whatever reason, but if I look up here in the formula bar, I can actually see which column was removed in that particular step. So that's quite a handy thing to do. Other places we can write M are in Visual Studio, if you've got the Power Query SDK. The Power Query SDK is an add-in for Visual Studio. It's free. It's meant to be for people who write custom connectors, but it also does allow you to write M queries and execute them inside Visual Studio. The UI for the queries and executing them is not all that great, but it works. There is also an M language add-in for Visual Studio Code. This is my code crib sheet for this particular session, and I've got the M language add-in installed, and then I can see here all of my M code, again, with IntelliSense, with color coding. I can't execute my M code in Visual Studio Code, unfortunately. There's a couple of other places as well. Oh, I forgot, if you're writing data flows, we can go to Power BI. Here's the Power Query online editor for creating a data flow. I can right-click. There's an advanced editor here, although in this case it's not very advanced because we don't have IntelliSense here yet, but I can still change and edit the code. I can also copy and paste code from Power BI Desktop from the advanced editor there into the advanced editor here, which is a nice, easy way of moving your queries up to data flows. And there are a couple of other places. So a guy in Germany, Lars Schreiber, has created a Notepad++ extension for M if you want to work in Notepad++. So lots of places to learn M. Now, let's get on and learn some M. A couple of things to say before we carry on. Unlike DAX, M is a very, very, very simple language. So at the end of this session, you will know pretty much all you need to know about the language of M. M is not DAX, though. A lot of people get very confused when they start out with Power BI because there are two languages in Power BI, which I can understand why they get confused, but it's very important to understand that when you're in the Power Query editor, what you're going to be working with is M and not DAX. M is case sensitive. So if you're writing your own M code, you need to be aware of capital letters. If you're not, then bad things happen. It's also a functional language like F# and other things like that if you're into programming. The last thing, and probably the most important thing to say about M, is that unlike other languages, it is not a language where you start off with the nice simple UI, it takes you so far, then you find you've got to write some code, and then you can never go back. The great thing about M and the Power Query user interface is that you can use the Power Query editor user interface to build your queries, to do 90% of what you need to do, and then when you find you've got something a bit tricky and advanced to do, you can open up the advanced editor, write a little bit of M code, and then you can go back to using the nice, easy Power Query editor. So you can mix and match, you can flip and switch between using the user interface, using the language. This is partly as a result of the way the language and the editor have been designed. It's not like a lot of other things where you're not going to be able to go back afterwards. It's really good in that respect. So we've talked long enough. Let's actually write some M code. In M, we have expressions, and expressions are evaluated and return values. Every query inside the Power Query editor is a single expression which returns a single value. All right, let's go back to the Power Query editor window. Let's open up the advanced editor. Let's delete all this so that we start with a genuinely empty query. And let's increase the size here. And what's the first program that we write in any programming language? It is there's Hello World in M. That was difficult, wasn't it? So I'm going to click Done. There's my query. It's executed. It has returned a value. So remember, this is important. Every query is a single expression which returns a single value. We can see the data type of the value returned here. It is text. It's a little bit grayed out. I think this is a bug in the UI. But this ABC icon, the same icon that you'd see on a column header, tells us that our query returns a value of type text, which is Hello World. Most of the queries that we write using the Power Query user interface will return tables, but our queries do not have to return tables. So this is a query that returns a bit of text. Let's get a little bit more advanced. Here's another expression. I'm sure you can guess what this is going to return. Hopefully you know what 1 + 1 is. It is 2. There we go. Our query returns the value 2. You will see now the icon here is changed, and that 1, 2, 3 icon tells us that we returned a number. Now, I know what you're thinking. You're thinking that there is no way that all of those complex M expressions that you might have seen when you've opened up the advanced editor, when you've been building queries at the Power Query editor, could possibly be single expressions. But they are. They are through the magic of the let statement inside M. So a let expression allows you to break down a single large expression into multiple smaller, easier to write, easier to understand steps. So let's see how we can write a let expression. Every let expression has a let clause and an in clause. Oh, hold on. And in the let expression, we have a series of variables or named expressions. So let's say step 1 equals 5, step 2 equals 3, step 3 equals, the expressions in each variable can refer to other variables. So I can say step 1 times step 2. You can see that I've got a comma-delimited list of variables. So step 1 and step 2 have commas after them. Step 3 does not, because it's the last one. And then in my in clause, I have the expression that the entire let expression is going to return. So let's return step 3. In this case, I'm sure you can probably guess that our query here is going to return the value 15. So if I click Done, you can see that it does indeed return 15, which is not really very interesting. But let me direct your attention over to the query settings pane on the right-hand side. Now, again, if you're familiar with how the Power Query Editor works, you will know all about queries and steps. Note how the 3 variables in my let expression have become the 3 steps inside this query. So every single query created by the user interface, consists of a let expression. Each step becomes a variable in the let expression. So that's all pretty straightforward. I've now got a query called query 1. We've seen how steps in the query can refer to other steps. We can have steps in a query that refer to the output of other queries as well. So if I create a new blank query here and go to the advanced editor, I know what query 1 returns. I can go here and I can say, give me the value of query 1, add 1 onto the end of it, click Done, and now query 2 is query 1 plus 1. So, all pretty straightforward. Something we'll come back to, but I'm going to stress right now. This all seems very much like procedural code, but it isn't. The way you have to read a let expression is from the end backwards. The way that the Power Query engine evaluates a let expression is from the end backwards. What do I want to return here? Well, I want to return something called step 3. What's step 3? Well, here's step 3. Let's evaluate this. It's step 1 times step 2. Well, what's step 1? It's 5. What's step 2 times? It's 3. So you work backwards. My let expression can return any value here, and the variables can be in any order. So if I go here and I change the name of this to be step 2 and step 1, easier than cutting and pasting, I can swap things around. I could even go and take this, put this up here. I have to be careful with the commas. I can completely rearrange my steps, and I click Done, and it will return the same value. You will notice that it's messed up the applied steps pane, but it doesn't make any difference to how the query actually runs. I could also go into here and say, instead of returning the value of step 3, I could just return any old value that I want, and that will all work as well. Because, of course, if we're evaluating from the end backwards, well, I'm evaluating the value 999. None of those values need to be those other variables need to be evaluated, so yeah, why bother? Okay. So, let expressions are pretty straightforward. Another important thing that we're going to have to learn about is data types. Now, we've already seen how an M expression can return a number. It can return text. There are all of the obvious primitive data types like dates and so on. But there are three important structured data types in M that you are going to need to learn about because they come up all over the place. We need to learn about lists, we need to learn about records, and we need to learn about tables. We'll also see in a moment that a function is a data type as well, and we can return functions from a query. But let's concentrate on lists, records, and tables, first of all. Let me go to my crib sheet, and let's have a look at lists first. Here is a let expression with a number of lists in. So let's just delete that. Let's open up the advanced editor. Let's delete everything we had before. Let's have a look at this. So based on what we've just learnt, I've got 4 variables here. My in clause is going to be able to return anything that I want. And let's just start off by returning the value of the fruit variable here. This fruit variable returns a list. A list is an ordered list of values. It is written as all of those values in a comma delimited list enclosed with curly brackets or braces or whatever you call. So here we've got a list called fruit. There are 3 items in the list. They are 3 text values, apples, oranges, and pears. So if I run this query, you can see the items in the list. The Power Query editor has some special functionality for displaying the contents of lists. Here you can see I've got this List Tools tab open, and I can see the items in the list. Now, the values in a list can be of any data type. They could be numbers, they could be text, they could be dates, they could be other lists. There is no rule about what can be in a list. You can mix and match and do whatever you want. So if we have a look in here, and we have a look at number, here is a list that returns 3 numbers, 1, 2, 3. And there are my 3 numbers. I can have lists that contain lists. So if we go to fruit nested, here is a list. There are 2 items in the list, both of which are lists, which both contain 2 lists. If I click OK here, there are my 2 lists. With anything in the Power Query editor window, if you click inside the cell but not on the clickable link, so if I click inside the cell here, the preview window appears and I can see the contents of the list, which is quite handy. The last thing to say about lists is that if you're writing a list of numbers, there is a nice, easy syntax for creating a list of consecutive numbers. So 1.5 here allows me to create a list of all of the numbers from 1 to 5. So if we do this, there's my list of numbers from 1 to 5. So that's all pretty straightforward. So every time you see curly brackets, from now on, think list. Let's move on to records. Records you can think of as being tables with just 1 row in. If we have a look at some examples of records here, let's look at names first of all. This is a record with 3 fields, speaker 1, speaker 2, and attendees. You can see the 3 fields have got names, and the 3 fields have got values associated with them. If I run this, this is the special way of displaying a record here. The Record Tools tab is open. I should have also pointed out that the icon changes for lists as well. But we've got a new icon here for a record. So this is what a record looks like. So remember, a record, just think of it as a table with just 1 row in it. We can, again, have nested types here. So if I look at the second expression here, records with other types, you can see that we've got a record with 3 fields. The first field, fruit, contains a list. The second contains a number. The third contains another record. We click done. And there's our nested list. Sorry, nested values inside our record. So that's all pretty straightforward. We've got lists, we've got records, we've got tables. Now, we've got a syntax for defining tables, which is pretty straightforward. We can use this hash table intrinsic function, which will give us a table. What we've got here inside hash table is, with the first parameter, a list of text values, which are going to be our column names. And then we have another list. There is one item in this list for each row in the table. And then each row is represented by yet another list. And each item in here, in the nested list, represents the values on each row. So if we have a look at this and then we run it, you can see I get this table back. So I can magically create a table out of thin air like this if I want. You'll notice that if I use this particular syntax, the data types for each column are set to any. It's not too hard to change the data types if I want, but there is another way of writing this. I can actually define a table here using this particular syntax, where in the first parameter I define a table type. This is maybe a little bit advanced for this presentation, but here in the first parameter of hash table, I define a table type. I define not only the column names, but also their data types. The same data is in place. And now when I click this, you will see that the table I've created automatically has its column data type set. All right, that's enough theory. Let's go and do something useful. So let's delete this. And the first thing to do is let's connect to a CSV file. This is not a very interesting CSV file. It's a CSV file with a month column and a sales column in. We'll click OK. And there's the data. You'll see that my query already has 3 steps in it. Maybe if I was to do a little bit of filtering on here, April, August, December, click OK. We've got a 4th step. Let's go and have a look in the advanced editor. Now, hopefully this is now not as intimidating as it used to be. What can we see? Well, I can see a let expression. I can see 4 variables. I'm returning the value hash filtered rows. Now, what's this hash all about? When a variable name or a step in a query contains a space, it has to be preceded by a hash sign and put in double quotes so that it's not confused as a bit of text. So that's all that is. We've got a step called filtered rows. What's filtered rows? Well, it's got some function stuff here, which I'm not going to go into just yet. But the first parameter for table.selectRows here is change type, which is defined here. This uses a function called table.transformColumnTypes, which sets data types on columns. It sets it on a table. It's the table defined by hash promoted headers. What's promoted headers? It's that. And you can see that refers to source, which is this. So we can now hopefully read and and understand what's going on in the queries that have been generated. And if you're debugging, it can be quite helpful to say, well, perhaps what does promoted headers return? Let's click done. And I can see what each step returns and just ignore the rest of the query without even having to comment out. All right, let's look at that. Let's leave that. So we understand a little bit about what's going on. Let's move on and talk about positions and lookups. So we've seen about records, we've seen about tables, we've seen about lists. We can extract items from tables, records, and lists using the syntax. We can get an item from a list using braces. We can get a field from a record using square brackets. And we can also put this together to get individual values from cells in a table by using a combination of the two. Because it turns out a table is like a list of records where each row is a record, or it's a bunch of columns where each column contains a list. So, we can think about a table as being something like a combination of a list or a record. If I go to here, let's see a nice simple example of this positional operator. So here I'm saying, give me the item at index 2 of fruit. This is a zero-based language. So when I ask for, sorry, not numbers 2, let me change this to fruit 2. So give me the second item in here. What I actually get is pears, and pears is the third item in the list. If I change this to 0, I'm going to get apples. So pretty easy. I can get the zero-based item from a list. We can get items from a record pretty easily. So if we go back to here, I can say, give me the field speaker 1 from this record, which will give me the text value Chris. There we go. And like I said, we can use this to get values from tables. So if we go back to our original table that we created out of nothing, let's put that in there. My output is source 1. Source is the table. What do I get? I get the second row. I can also get the value from values in columns A. So let's do this. So if I say source A, this will give me all of the values in column A, which should be 1 and 4. There we go. There's 1 and 4. Now, let's put this to good use. Let's go back to that CSV file that we were looking at. And let's say that we wanted to get a value out of a cell. If I right-click on a cell, I can do that pretty easily by going to drill down. You can see that it automatically generates that syntax that I just showed you. But let's say now we wanted to do perhaps something more interesting. We want to do a calculation. We've got sales by month. Maybe we want to be able to do some kind of previous period growth. We want to be able to compare the value on the current row with the value on the previous row. Now, generally speaking, this might be something you'd prefer to do in DAX, but let's say we want to do it in M instead. How can we do that? Well, one way of doing it would be to add a column. Let's add an index column, which gives us a row number starting at 0. Let's add a conditional column now. So in this conditional column, what I want to do, sorry, not a conditional column, a custom column, what I want to do is get the value for sales for the previous month, the month on the row before the current month. So let's call this previous month sales. What I need to do is first of all reference a table. What's the table that I want to reference? Well, it's the table that's returned by the previous step added index. So here, if I say added index, that gives me the table returned by the previous step. I want to get the row before the current row. So I'm going to need to use this curly brackets operator to get the row before the current row. What's the current row number? It's the value in the index column. Let's subtract 1, and let's get the value from the sales column using that lookup. Click OK, and I'm almost there. So you can see that this is this, this is this, this is this, and I'm pretty much on my way to being able to do my previous period growth calculation. There is a problem, though. We've got an error. We've got an error because there was no month before the January month, and so our lookup fails, which leads us nicely onto dealing with errors in M. Errors in M can be handled very nicely using a try otherwise statement. We open up this, a custom column editor again. This is the expression that we want to return. I can add try. This will evaluate the expression. If it returns an error, I can just say otherwise 0, and otherwise tells us what the expression is going to return in case the try block returns an error. Click OK, and the problem's gone. Now, the UI's got a little bit confused here. Sometimes it realizes that the error is gone, sometimes it doesn't, but we have actually solved the problem. So errors are nice, easily handled using a try otherwise statement. Functions. We've already seen that there are lots and lots of functions built into the Power Query language. The good thing about Power Query is that we can define and use our own functions. And, as I've said, the M language thinks of functions as a data type, which means that we can have queries that return functions. Okay. First thing to mention, a few useful bits and bobs. Let's create a new blank query here. If you ever want to see a list of all of the functions that are available to you at any one time, you can just use this shared intrinsic function, click done, and it returns a record with one row for each function that's available in the current context. So we have a look at pdf.tables, click on there, you can actually see the documentation for this function in here. Sometimes the documentation here is more up to date than the documentation in the Microsoft website. This is in fact how I think they generate the documentation. Something else interesting is if you do want to just see the documentation for an individual function, like pdf.tables, you can write the name of that function without the brackets. This returns the function without calling it, and here I can see the documentation again, which is pretty useful. So if you're working offline, you can get your documentation anyway. All right, so those are the built-in functions in the standard library. Let's define our own functions. We can define our own functions pretty easily, simply by writing something like this. So here's a function that takes two parameters, x and y, both of which are numbers, and I'm going to return a number. And my function here is just going to simply take x and y and multiply them together. Click done. You will see now my query 1 returns a value of type function, and I've got the UI here that I saw for a built-in function, and I can invoke it and test it. So let's type 7 and 8 in here, click invoke. It invokes the function by calling query 1 with 7 and 8, and I get 56 back. Functions defined like this are really useful for encapsulating more complex logic for transformations and things. You can, of course, change the name of your function query. Let's call this mult. And now I've got a function called mult that I can use in other places. Instead of clicking invoke here or writing my own code, something else that's pretty useful is that in a table, I can go to add a column and invoke a custom function on a table once for each row in the table. Now, if I click this invoke custom function button here, it asks me what my new column name is going to be. It's going to need a query that returns a value of data type function. Here's mult. It needs x, it needs y. I could type in a value here. I could take a column name and let's just say sales. This will multiply sales by 5. And now I've called my function once for each row in the table, which is also a pretty useful thing. One other thing to point out is that if you've been looking at M code that's generated by the UI, you will have no doubt seen the each expression in a lot of places. Each is just a shorthand way of defining a function that takes one optional parameter whose name is underscore. Lots and lots of the built-in M functions expect to call a function in their second parameter. And the UI, when it calls those functions, will simply define that function pretty easily just by using an each expression. So if we go back to here, let's grab each like this. If I define a new custom function, let's go to new source, blank query, advanced editor. This defines an unnamed function that takes that one parameter. I'm going to take that parameter, multiply it by 2. You can see it returns a value. And then again, I could go to add column, invoke custom function. There's my new query. Let's take all of the values in index and multiply them by 2. And there we go. So that's all an each expression is. It's just a way of defining a function with no name that takes that single optional parameter. If you are wondering a little bit about what happens here, let's get rid of this. Let's go to add column and let's add a custom column here. Now we know that when we have a custom column, it's going to create an each expression for me. If I just put underscore here, which is the name of the parameter passed to that, and click OK, you'll see what I get back is a record for all of the values on the current row. And the good thing about this, let's do this, is that I can now use this to reference the values on the current row. So for example, I could say sales, and when I'm in an each expression, I don't even need that underscore here. That's optional. That's why this field syntax just works. And there I've got the values in sales. Calling web services, like I said, is one of those common scenarios where, for example, you are going to have to write some M code sooner or later. Depending on how authentication works, you might even need to write a custom connector. But simple web services you can call by using the web.contents function, just like anything else. You can only make get and post requests. There are going to be lots of situations where stuff works in Power BI Desktop that doesn't work after publishing. If you come to my session immediately after lunch, we will learn more about dealing with web services and these scenarios when stuff doesn't work. But I'm just going to give you a very quick example of calling a web service and turning it into a function. So I've got a simple web service here that does a search for some open data, and my search term is cows. It's a REST API. There's no authentication. There's nothing to worry about. This is the web.contents function that calls that API. It brings back some JSON. The JSON document function turns that into something useful. Let's copy this. Let's create a new blank query. Click Done. We've called the web service, and we've got our JSON back. It returns a record. We can drill down, and we can see the contents of the records. That's not so interesting. That makes a GET request. If you want to make a post request, you're going to have to include the second parameter of the web.contents function. I'll point out that this second parameter is in the form of a record. We've got square brackets. If I use this record and I create a field called content in the record, that is what's going to be passed in the body of the post request. So as soon as I've got this second parameter with a record in, and I add the content field to that record and pass a value in, that's going to be what's passed through, and this will turn this into a post request rather than a get request. This web service is one that I built in Flow that takes a bit of text and translates it to French. So what we should see from this, when I call this as a query, we should see the French translation of "Hello everyone, how are you today?" Let's drop that in here. Click Done. And there's the result. And this is a useful web service. Perhaps we've got lots of text that we want to translate. I know that the data flows can do this now, but if you don't have premium, you can take this approach instead. Let's take my query. We'll turn it into a function. So input text as text. I'm going to pass that text into here in the text to binary function, and we'll be able to call any text, pass any text to our web service. And this, I think, illustrates how useful functions are, because now I've got a function. What a nice day. Click invoke, call the function, and here we have quelle belle journée. Any Canadians in the audience? Any French people? Any Swiss? It's the right translation, more or less. So we can do that. And of course, if we had a table, let's create a table out of some thin air. Let's go cheese, bread, wine, all things very dear to a French person's heart. Here is a table containing 3 text values. We've got a function. We know that we can call a function once for each row in a table. So let's go to add column, invoke function. Query 2, I think, was the one that we wanted. We'll pass in the values in column 1. Click OK. We'll call the web service 3 times. And we've got the 3 translated values, which I think nicely illustrates just how useful functions and web services are. There's a lot more to say about this, but it gives you a good introduction, I hope. Last 2 things. This is where we're going to get a little bit more advanced, but these are fundamentally important concepts to the language. Now, as I said earlier, M is not evaluated like procedural code. It's evaluated from the end backwards. What's more is that for certain types of data type, the engine will not only evaluate from the end backwards, and it will not only ignore variables that are not used, it will also ignore bits of data that are not used. Now, this can be really, really confusing. But what I'm going to try and do is illustrate this and illustrate how you've got to think in M. Now, let me explain what this query does. I think it illustrates the problem quite nicely. Let's create a new blank query. And let's look what we've got. We've got a source step, which has a list with 5 numbers in. Now here, I'm defining a function called waitAsec. I pass a value in, and it will return the same value, but it uses this function.invokeAfter function, which will simply wait for a given amount of time, which in this case is 1 second. So I've got a function, it takes a value, it will return the same value after a second. I'm now going in the call function step to loop over this source list using the list.transform function. And for each item in this list, I'm going to call wait a sec. So ultimately, I'm going to get the same value back. Now, we'll not look at the first value step here. Let's just go to call function. So we're expecting it to loop over this list of 5 values, wait for a second. It may well do this twice. But the important thing is, when the query runs, it is not going to run immediately. It will take at least 5 seconds, and certainly 10 seconds. And if you're on stage looking at an audience, it's probably going to feel like 20 seconds. But the point is, it has taken a long, noticeably long time to run. Let's look at this last step here, called first value. And what does it do? It uses the list.firstN function to get the first n items of this call function list that we were previously returning. And I'm saying here, get the first 1 items from this list. So this is going to return a list with 1 item in. Now the question is, how long is this query going to run? Is it going to run the same amount of time as it did before? Or is it going to be quick? Let's click done. It's quick. Now the reason I've done this is because even though I've told you that M is not procedural, you cannot help but think that M is procedural. You're going to look at this, you're going to look at this list of steps, and you're going to think, there's the list, here's my function, I'm calling that once for each row, each item in the list. That will take 5 seconds, and then once I've got that list which takes 5 seconds to evaluate, I'm going to get the first item out of it. But that's not what happens. What happens is that I want first value. First value, when you think from the n backwards, says give me the first n item of call function. Call function takes a list, but I know I only want the first item from it. So instead of looping over every item here, it's just going to stop at item 1. So it's only going to call wait a second once, so the query only takes a second to run. This is really confusing, but really important, because if you're working with large amounts of data, you don't want to call that function 5 times. You want to do things as efficiently as possible. And the interesting thing is, and this is something that I'll talk about in my session later on, this can extend back before the query. Because when an M expression is evaluated and you're working with certain types of data source, you will find that in actual fact, it will take this, it will do something similar, and it will push that work back to the data source in a process called query folding. Time for one last mind-bending demo, something very similar as well. Lazy and eager evaluation. M is a partly lazy language, which again leads to lots of confusion. Data types like tables, records, and lists are only evaluated when they're needed. Data types like numbers and text are always evaluated. Variables are only evaluated as and when they are needed. So, just to prove that is with variables, again, if I just say, let's return source here, I only want this list, none of this is going to be evaluated. Click done. We get our list back instantly with no waiting at all because we're never calling our function. But, like I said, things are going to be a little bit more confusing if you're working with, for example, SQL Server data sources. So I'm going to connect to SQL Server and I'm going to run a profiler trace. Don't worry too much about this. Just understand that it's going to allow me to see when a query is run against my SQL Server data source. And then, let's have a look at this query. Or actually, let's look at this query first of all. This query connects to that SQL Server instance, and it returns the contents of the dim date table in the AdventureWorks database. So let's create a new blank query here. I could have done this by connecting to SQL Server and going through the UI, but it's just quicker to cut and paste. There's the contents of dim date. We'll call this dim date. If I refresh this, well, it's already refreshed, you'll be able to see, let's refresh this because it's cached it, that there's some query stuff happening. Now, confusing thing is that it will hit this to try and get some data to populate the preview window, but we're going against SQL Server. Now, let's have a look at another query here, which is nice and simple. It's got a simple logical test. If 1 equals 0, then return the value of dim date, otherwise return 0. Now, the interesting thing is, if I click done here, and I refresh this, are we going to get data from SQL Server? Well, we are, because the UI is going to update. But the key thing is, if I look at this and I refresh, you can always tell the queries that are used for populating the cache used by the user interface, because they are going to be ones that you have a top 4096 in. And in fact, in this case, when I did a refresh, I'm lucky today, absolutely nothing happened. So that table was not queried. We didn't go back to SQL Server, which is kind of what you'd expect, because that's never going to return true. If I change my original query, though, to return a number, which is the number of rows in that table, so table.rowCount returns the number of rows in the table, my original query does not return a table anymore. It's going to return a number. And numbers are always evaluated when they're encountered. If I go back to here, there we are. That's it asking for the row count. If I get rid of that, and I refresh my query here that says if 1 equals 0, then dim date, we refresh the preview. We're still not getting anything back, but what we should see, if I am lucky, is that I should have seen that query being hit. But I think I've made a mistake there. Anyway, one demo going wrong isn't bad in the whole thing. You have to take my advice that it will hit that. Okay. We're finished. We're out of time. We've learned everything we need to learn about M. In summary, as I said, M is not something you're going to really absolutely have to learn when you first starting learning Power BI. It's not going to be something you probably need to worry about even after you get to an intermediate level. But I think anybody who wants to get to a kind of truly expert level in Power BI really needs to know a little bit of M. You don't need to write M queries from scratch. You just need to be able to tweak queries to be able to do some useful stuff. But then if you really want to go to the next level and do advanced stuff with web services, you can't avoid it. But it's a nice, easy language to learn. The syntax is very basic. There is really nothing much more than I've covered in this hour. And personally, I think it's a lot easier to learn than DAX as well. So go away, have a go, play around with it, and hopefully this gives you something useful that you can take away for your job. Thank you.